Okay, for example 7, A part 1 and part 2. Okay, just now I have already screenshot the solution, and this one I think is quite easy to understand. Okay, now I'm going to show you example 7B. Okay, this is STPM 2019. Okay, given that y equal to the exponential arctangent 2x, and then show that 1 plus 4x squared d2y dx squared, and then all this equal to 0. And then we are asked to use Maclaurin series, and we want to expand until x power 3. So if you want to expand until x power 3, that means we are going to differentiate until d3y dx cubed. Okay, so now I just show you how to get this. Okay, now okay, now look at this here. Okay, now I'm going to start. Okay, here given this. Of course, we are going to differentiate. Okay, now the first derivative. Okay, I can write this one as ln y equals to arctangent 2x. I feel that like this will be easier to differentiate by using the explicit form, is it? Okay, here when I differentiate this 1 over y dy dx, differentiate this arctangent is 1 over this one square, and then differentiate this, you get 2. Okay, now then you see, then we simplify, you get this. Okay, but according to the question, we are going to differentiate second time. We are going to show second time we are going to differentiate the second derivative. So we are going to differentiate this. So we are going to differentiate this, okay, both sides. So you see, before we differentiate, we can write like this as well. We can write it like this. That means the 1 plus 4x over here, the y over here. So now you compare this one with this one. Which one will be easier to differentiate? Of course, it's this one. That's why we start with this. Furthermore, if you look at the question again, you see this is 1 plus 4x squared d2y dx squared. So you want to get this term. That's why you write like this. That's why you write like this will be easier to differentiate. Why? Okay, here we have 2 persons. We are going to differentiate. So when you differentiate this one, you get 1 plus 4x squared d2y dx squared. Differentiate this, and then plus, okay, this one you just differentiate 8x, then dy dx, differentiate this one is 2 dy. Okay, so you see, now we have already got this. That is how we do. You see, we have already got this. Same, these two is the same. Okay, then we just simplify only the rest. Okay, so when we simplify, then you will get the answer. This is what we are going to show. And then here I label 1, 2, 3 because later after the Maclaurin Theorem, we need to substitute x0 here, x0 here, x0 here. Okay, x equal to 0. Okay, so because we want to get until x power 3, so we have to differentiate one more time. That is, we are going to find d3y dx cubed. So when you want to find d3y dx cubed, you just differentiate. You see here we have 2. So this one, keep it, and you differentiate this. Plus, differentiate this, then this one just maintain it. Okay, like here also. Here you differentiate this one d2y dx squared, plus here you differentiate 8x, you get x. Then you get x, you get 8. Then this one you get dy dx equal to 0. Okay, this is your d3y dx cubed. Actually, you don't have to simplify this because this we are going to differentiate until x3 d3y dx cubed only. But anyway, if you want to simplify, also not so difficult because here d2y dx squared we can combine together. We get 16x minus 2, and then this one. This is what you get. Okay, so just now you are asked to show this one. We already got it. That is number 3. Okay, the part A. You are asked to show. You are asked to show. That is part A. Okay, we got it already. That is number 3. Okay. Okay, now we are going to use the Maclaurin Theorem to get the expansion, the series expansion for our function given. Okay, so we substitute, as what I said just now, we substitute x equal to 0 into 1. Then when you substitute x equal to 0 into 1, you will get e to the power arctangent 0. So this one you get 1. Okay, then after that you substitute. So substitute into 2 here. Okay, so your x is 0. So 1 plus 0 dy dx equals to 2. Okay, just now the y from the first one, the y is 1, is it? So you substitute the y, so you get 2. Okay, then after that you substitute again, x equal to 0 into 3. So you substitute 0 here, substitute 0 here. Okay, and then your dy dx you get is 2, so substitute, then you simplify. Okay, these are all quite simple, but must be careful. Okay, then you substitute this one, okay, into our 4. 4 is here, this is 0, this is 0. Okay, then d3y dx cube, then this is 0, you get negative 2 d2y dx square, which is 4 from here. d2y dx square is 4 inside, and then here you have 8 dy dx. Okay, what is dy dx? Here is 2, so substitute, and then you simplify, you get negative 2. And then after that you just use the what we call our Maclaurin theorem. What is Maclaurin theorem? This is Maclaurin theorem. Okay, what is Maclaurin theorem? Maclaurin theorem say that this is the thing, so we just substitute whatever value that we have got just now. Okay, we substitute the f0. Okay, we substitute the f0, f prime 0, which is 2, and then f double prime 0, and then negative 8. So once I substitute, I will get this. Okay, I substitute all these value, I get this is what I get. So then I simplify, then I will get this. Okay, finished. So that is the Maclaurin, what we call the Maclaurin series for exponential arctangent to x. And then after that the question is, hence evaluate this. Now I want to find the limits of this. Of course, you want to find this limit, you cannot use what we have learned in chapter 1 last time, okay, beginning of semester 2. This one we cannot use that method. We have to use Maclaurin series to show. Okay, so here you see I'm going to find the limits of this. So since I want to find the limits, I just substitute the y. Y is this one, this is y. So I substitute everything inside, and then minus 1 over this. So I get the 1 and 1 cancel, that's why I get this 2x, all this I get. Okay, then you see the top one and the bottom one, actually this one I can factorize. I can take out the x. So once I take out the x, I can cancel the x. These two x can be cancelled because this is not 0. This is a very small number. Okay, it's an electron and an electron. That's why we cancel. Okay, it's not 0. Okay, so here you have, after you cancel, you get this. Okay, and then you can substitute 0 inside here. So when you substitute the x to be 0, you get 2 plus 0 minus 0. Here also you get 4 plus 0. That's 4. Finally, you get the answer is half. So that is the way how to get the answer. Okay.